Every year, global temperatures rise. Cities are becoming heat islands, trapping heat and making urban living unbearable. The Gulf region, especially Bahrain, experiences some of the harshest conditions, with temperatures exceeding 50 degrees. In response, air conditioning, ACs, has become essential. But at what cost? Buildings consume 40% of the world's total energy, with over 70% of household energy in Bahrain dedicated to cooling. The problem? AC is expensive, increases pollution, and contributes to the urban heat island effect, making cities even hotter. The current approach is reactive, cooling spaces after they've overheated. We need a smarter, proactive strategy. Traditional solutions, thicker walls, reflective coatings, and high-powered AC units are only short-term fixes. The Gulf's architecture has been slow to adapt the extreme climate, relying on outdated materials that trap heat instead of managing it. Conventional materials like concrete and glass absorb and retain heat, making interiors hotter. Most energy-efficient solutions focus on exterior changes, facades, shading, but interior surfaces play a huge role in thermal comfort. Our focus is different. We redesign interior finishes to control heat before it becomes a problem, reducing the burden on AC systems. Imagine a home or office that adapts to heat in real time, absorbing excess warmth during the day and releasing it when temperatures drop. Instead of fighting the heat, our materials work with it. This is the power of heat-responsive interior finishes. The first innovation is phase-changing material walls. Think of these walls as thermal batteries. PCMs store excess heat when temperatures rise and release it when it's cooler, reducing AC usage by 30%. It's like having a built-in climate control without the energy consumption. How does it work? PCMs absorb heat at peak hours, delaying heat transfer into the room. Why it's unique? Unlike traditional insulation, which only slows heat transfer, PCM actively regulates temperature. The impact? It can lower indoor temperatures by 3 to 5 degrees, cutting cooling costs significantly. The second innovation is cooling plaster finishes. Walls don't just enclose a space, they dictate how heat moves within it. Our cooling plaster contains reflective microparticles that prevent heat from being absorbed, keeping walls up to 80 degrees cooler. How it works? The plaster's microscopic layers reflect infrared radiation, stopping heat before it enters the building. Why it's unique? Most insulation focuses on trapping air, but this directly reduces surface temperature. The impact? It reduces reliance on air conditioning and enhances overall indoor comfort. We tested these materials in BIM simulations for Bahrain's climate, applying them in both residential and office spaces to measure their effectiveness. The key results? Indoor temperatures dropped by 5 to 7 degrees, and it was up to 40% less electricity used for cooling. There was reduced heat stress, improving indoor air quality and occupant well-being, and there was less humidity, leading to healthier indoor environments. This isn't just theoretical. Our approach proves that sustainable interiors can be done without sacrificing comfort. Cooling isn't just about turning up the AC. It's about designing smarter spaces. Our approach shifts the focus from external fixes to interior innovations, reducing cooling demand at the source. Imagine homes that cool themselves, offices that stay comfortable without overloading power grids, and a future where energy savings become a standard, not an exception. Bahrain and the GCC have the opportunity to lead in climate-responsive interior design. The future of cooling isn't just in new technology, it's the materials that we use every day.